So hello and good morning to everyone. So our today's lead code question is 3634, that is minimum removals to balance an array. So basically we are given an array of integers and an integer number k. So first of all, what is a balanced array? So an array is said to be balanced if its maximum element is at most k times the minimum element. Means the condition is that the maximum element should be less than equal to k into minimum element, right? And what we have to do is we can remove any number of elements from nums without making it empty. So what we have to do is we have to remove elements from the array, so and we have to make it balanced, and at the end we have to return the minimum number of elements to remove so that the remaining array is balanced, right? And also it is given that array of size 1 is considered to be balanced, right? So let's see some examples to understand the question properly. So first of all, we are given 2 1 5 and k is equal to 2. So, which element should we remove so that we get the rest of the array to be balanced, right? So, if we'll remove 5, we'll get 1 and 2. So, 1 and 2 is balanced because the minimum element is 1 and maximum element is 2. And 2 is less than equal to 1 into 2, right? So, we will be removing 5 here. Next, k is equal to 3 and the array is 1 6 2 9. So which element should we remove to make it balanced? So suppose if we remove 1 and 2, then we get 6 and 9. So 6 3 is 18. So 9 is less than 18. So yeah, this is also balanced. Next we have 4 and 6 and k is equal to 2. So 4 2 is 8. So 6 is already less than 8. So we don't need to remove anything, right? Let's see the constraints. So if you'll notice the constants, the array length can be up to 10 to the power 5. What does that mean? That means we have to find a solution of either big of n or n log n. We won't be we won't be allowed to use a solution of big of n square. These two solutions, either n log n or big of n, right? And nums of I can be up to 10 to the power 9, and k can be up to 10 to the power 5, right? So let's see the approaches. So if you'll see the question, what we want in the question is we have, if we'll simply modify our question statement, that is like we have to remove elements we such that the array left is satisfy the condition that the maximum element should be less than equal to k times minimum element. So can't we just say that we want to find the longest subarray such that this condition satisfied, right? So earlier our question was we have to remove elements such that the remaining array is balanced. So instead of doing that, we will be modifying that question to finding the longest subarray such that maximum element is less than equal to k times minimum, right? So if we'll see the brute force, what is our brute force? We will be finding all subarrays and then check all the subarrays. But in worst case, its time complexity will be big of n square. So the constraints won't be allowing us to use brute force. So what we can do is, so so instead of finding the all the subarrays, what you can do is, so suppose if I fix the smaller element x, then what will be our larger element can be? So our larger element can be k into x, right? And all the elements in this window from x to kx. So this is the length of the subarray, which will be our answer for this x, this particular smaller element x, right? Similarly, we can find same way for y also. So for y it will be from y to ky, and the length of this subarray will be answer for this y. So we have to find a subarray such that it should be the largest one, because then we have to remove the minimum elements. And so if we see for every element, right, we can see a window. So see, for x there is a window from x to kx. So can we use sliding window here? Yes, we can, but how? So let's see. If we'll What we'll do is we'll initially use two pointers, low pointer and high pointer, right? Low pointer will be at that minimum, yeah, that smaller element which we are considering now. Let's say we are considering x. So what we do is we will be keep shifting the right pointer until we do not get an element that is greater than k into minimum element. So we will be shifting this high pointer until we get an element greater than equal to k into kx, right? And once we get a bigger element than k into minimum element, then what we do is we will be finding the length of the subarray for that particular x, and that will be the high pointer or the right pointer minus left pointer plus 1. So this is the number of elements that are present in that window, and this is the length of the subarray for that particular x. And if you find the longest subarray, then we have to remove the minimum number of elements. So what will be our final answer? Final answer is array length minus longest subarray. So these are the number of elements that we have to remove, right? I hope you are getting it. So let me explain you with an example to make it more clear, right? So see, this is our nums array where we are given elements 2, 3, 10, 6 and 4, and k is equal to 2. So what we do is initially we will be sorting the elements, right? So after sorted, our nums array will be 2, 3, 4, 6 and 10. So our left pointer is at 0, right pointer is also at 0, and the element in our window will be currently 2. So it is given in the question that all the arrays of length 1 are balanced. So our window size is 1, and our best answer till now is also 1. So what we do is we now increase the right pointer or high pointer. So we shifted it to next element 3. So our now window is 2, 3, and the size is 2. So 2 is greater than 1. So our best answer is 2. Again increase to next index, that is 2. So 4 is equal to 2 into 2, right? So our condition is satisfied. So what we'll do is size has becomes 3. So best answer is 3. Next we move to index number 3, and at index number 3 we have element 6, but 2 into k is equal to 2 is less than 6. So our condition is not satisfying. So what we will be doing, we will be shrinking the window. So for 0, the length that we get is 3. So next we will be shifting the low pointer to 1. So here we have 3, right? So 3 into k is equal to 2, which is equal to 6. That is our maximum element. So yeah, condition is satisfied. So our window becomes 3, 4, 6, and the size is 3. But the max answer is still the same, only 3 only, because here also window size is 3 and earlier it was also 3. Now we'll be shifting our high pointer again. So high pointer went to 4, that is element is 10, right? But our smaller element is 3. So 3 into k, that is 2, is less than 10. So our condition has failed. So again we have to shrink the window. So we will be shifted the low pointer to 2. So now low pointer is up at element is 4. So 4 into 2, it is also less than 10, right? So again the condition is failed. Again we have to shrink. Next we shrink to element index number 3, where the element is 6. So 6 into 2 is 12. So 12 is greater than 10. So your condition is satisfied, right? So the window size is 2, and the best answer is 3. And now we can't expand further because our array length has completed. So the best subarray length that we get is 3, and our array length was 5. So 5 minus 3, that is 2. So we have to remove two elements. So now which two elements should we remove? So either we remove 6, 10, or either we remove 2 or 10. In both cases, the array will be balanced only, right? So let's see the code, like how we will be doing it. So first sorting the array, and our best answer or max length is 1, because it is given in the question that array length of 1 is balanced. So always our answer is 1. And int, this is our left pointer, and then we are shifting our right pointer. And while nums of element at right pointer is greater than element at left pointer into k, right? That is, max element is greater than k into minimum, then we'll be shrinking our window, then we'll increase our lower pointer. Else we'll be checking whether our max length equal to max of max length and r minus r plus 1, like how many elements are there in the current window. So this way we'll be updating it every time, as I explained you in the above example. And at the end, what we'll do is we'll return the size of the array minus the maximum length. So these are the number of uh, elements that we have to remove to make the array balanced. I hope I am able to explain you this question properly. So if you'll get, please make sure to like, share and subscribe the video. Thank you.